Hello, and welcome to the first Knowledge Exchange Tour Tuesday. I'm Dara, and I'm with the CFAES Knowledge Exchange. For those who don't know much about the Knowledge Exchange yet, or KX, our purpose is to bring together researchers, extension professionals, decision makers, and communicators to share, explore, and engage with the world-class research from CFAES. We do this through collaborations, building professional connections, and completing various types of projects. And today, we'll be connecting our audience with the Wilbur A. Gould Food Industry Center. The center is on the Columbus campus, and the two pilot plants you'll see reside in Howlett Hall and the Parker Food Science Building. Before we get started, I'll share a few things to keep in mind. This will be a webinar format, and any questions can be entered in the Q&A box at the bottom of your screen at any time during the tour. So please utilize that for any questions that you have for our tour guides. The chat box will be turned off though. Now, we are so excited to begin this tour. To kick us off, you'll be hearing a little bit about the Food Industry Center from the director, Dr. Valente Alvarez. He has over 30 years of combined experience in both industry and academia. I will now hand it off to Dr. Alvarez.
Thank you for the introduction and welcome to the tour. I'm Dr. Valente Alvarez. I'm professor and the Dairy and Food Processing Extension Specialist in the Department of Food Science and Technology. I am also the director of the Food Industry Center that you are going to be touring soon. Before I tell you about the Food Industry Center programs, I would like to explain what is food science for those who might not be familiar with our area. Food science is a very interesting, exciting, and multidisciplinary field because we deal with a product that everybody needs every day. Do you agree with that? Well, food science, as I said, is multidisciplinary because we teach and do research related to food chemistry, food analysis, food processing and technology, food engineering, food packaging, food microbiology and safety. So don't you think that's very interesting field to study? Well, the Ohio State University, through the Department of Food Science and Technology, offer all those teaching and research areas, and within the department is the Food Industry Center, which is part of the department. The Food Industry Center was established in 1982 to be the interface between the dairy industry, food industry, and the programs that the Ohio State University offers in food science and technology. To do that, the department and the Food Center have two processing facilities. The dairy processing pilot plant is located in the Parker Food Science and Technology building, and the food processing pilot plant is in Howlett Hall. These two facilities have a variety of capabilities where we can process different foods. On the dairy side, we can process and do research and teaching with fruit milk, cheese, yogurt, ice cream, butter, and other related products. On the other plant, we can process mostly fruit and vegetables, frozen foods, refrigerated foods, cereals, baking goods, extrusion products, etc. These two processing plants and facilities are available for students, grad students, faculty, food industry personnel, and most importantly, for our entrepreneurs in the state or in the country that want to start the food processing and packaging business. And you will see in the tours how these capabilities are used, and my highly qualified personnel, Gary Weniker and Matt Papik, who managed the food processing pilot plants, will show you, will talk to you about those very interesting equipment, and they will tell you how they operate, what kind of products can be done, and so on. With that introduction, I hope that you are already excited to learn about this, and I welcome to the tour, and I hope you will enjoy it. Thank you.
Great. Thank you, Dr. Alvarez. And now we will begin the tour portion of our virtual tour. And we will begin with Matt Papik, and he will be in the pilot plant that develops vegetable products and dry good products. And Matt is the laboratory supervisor and pilot plant supervisor, and I will let him introduce himself, and I will throw it over to Matt.
So good morning. I think I've had two people already introduce me, but my name is Matt Papik. I'm one of those highly qualified and capable personnel that was mentioned earlier. This is the Food Industry Center's fruit and vegetable food processing pilot plant. We operate 5 days a week. I'm here from 8 to 5 every day during the week. I get the weekends off because, you know, I need a little bit of rest, but we do have a lot of activities that are going on in here. As Dr. Alvarez mentioned, both my area and the dairy pilot plant next door in Parker are, we have students utilizing this area, we have researchers utilizing this area, and we have food industry representatives utilizing this area, and that runs the whole gamut. We have local and people within the state, typically entrepreneurs that are trying to start a food business, utilize this area to start food production and begin their business. And we have larger food companies that utilize this area for pilot plant trials, for research and development, and just general research, including things like shelf life and product improvement. So we'll go ahead and start the tour. If anyone has any questions, I'll check every couple minutes. There's going to be a lot to cover, so I expect a couple questions. If not, that just means I didn't do my job very well. So as we kick off, this is what I call kind of the most general use area. This is typically where most of our lab classes happen within the department. Most of my university activities are lab courses. So either we have students coming in with food science courses. We have had a handful of not food science courses that come in either for tours or lab classes. We have a main campus engineering course that actually comes in here every semester for a laboratory that they conduct down here. But I typically do it up here just because this is the most wide open area of the pilot plant. I have a lot of utility hookups. So I have the ability to hook up to steam. I have the ability to hook up to water, and of course, several different electrical hookups. So if I want to move a piece of equipment up here, if it's able to move, it's pretty easy to do. I have the capability of plugging it in and starting it. So this is a good area for versatility, and that's usually what you need for a lab class. The other reason we do it for lab classes is this behind me is kind of where our baking section is. So we have mixers, we have our proofing ovens, we have our regular ovens, convection ovens, conventional ovens, all that sort of stuff. And I've come to find out, especially undergrad, they like to bake things. It's, you know, it has a lot of different unit operations involved in baking, between mixing, baking, heat transfer, all that sort of stuff. So all those tenets of food science and just general food engineering all happen up here. It's very easy to do. So it's kind of a catch-all when it comes to student activities. As we move further back in the plant, we're going to see that we're going to be going into more areas of kind of more specified, highly specific areas that are going to be a little more non-versatile. There's pieces of equipment that won't be able to move. They're there for specific purposes. They're pretty rigid, and we aren't going to be able to move pieces of equipment in and out as easily. And the first section where that kind of happens is right here. This is our food sterilization section, our retorting section. So we actually have 3 retorts. We have a horizontal rotary retort here. This would be something that would be used for anything that's in a metal can if we want to be mixing our, okay, we're good. If we want to be mixing our product while we're cooking, so if you're thinking of things like tomato juice or any type of soup, this would be a perfect place to process that that particular item. And then over here, we have 2 vertical still retorts. They don't have that mechanical mixing, so it's a little harsher on your food product. It doesn't have that assistance of that mechanical mixing to kind of make a more high quality, evenly cooked product, but they're more versatile in the containers they can be processed with. So we can do glass jars in here, we can do retortable pouches, we can do plastic containers. We're not limited to metal cans, whereas with anything that is going to be mixing our container, we want to keep it in a metal can so we don't have any damage to our packaging. These are often used for research, especially our vertical still retorts, just because they're so versatile. So if someone has a new packaging idea or a new product, we're very familiar with using these pieces of equipment and how to apply them to different packaging and products. So they're one of our most frequently used items here. Just kind of going along those lines, we also have a continuous can closer here. So if you're running your typical 16-ounce can, we call them size 300 cans, we can run several hundred in an hour. So if you're looking at a big project, we have the ability to keep up with you. And this is kind of, in a nutshell, our thermal processing food sterilization section. Before I move on, do we have any questions in the chat?
Not right now.
Okay, cool.
Thank you.
That means either I'm talking too fast or I'm just doing a really good job and explaining really well. Another quick thing I want to point out, just because this is probably our most frequently used piece of equipment for research within the department. This is our cabinet freeze dryer. I actually have a project in there right now that's going to come out this afternoon, but it just has it's a robust piece of equipment as far as we can do as much as 30 liters at once. So we can do as little as a liter of product. So it's got a wide range. And we typically like to have things dried. It's something that is frequently used within the department, and it's pretty important to all the research that goes on within the department. There's not really too often this isn't running. So I just like to point that out. And as we move back, we start to get into other kind of more specialized sections of the plant. If we're looking here on my left, so I guess camera right, this is where we do or begin all of our tomato processing and vegetable processing. That typically ends up in our retort section where we finished our canned product, but we always start over here. We do a research with OARDC up in Fremont, Ohio. We do tomato research with them. We go pick up between 1,200 and 2,000 pounds of tomatoes every year, and we process them here. We have the ability to peel tomatoes with our chemical peeler. We do diced tomatoes. We do juice tomatoes. We do all of that here. We have all the equipment we need to have a full, robust canning operation as far as tomato processing. We do have the capability to do other vegetables. I know people say tomatoes are a fruit, but the FDA says they're a vegetable. So we'll call them a vegetable today. But we do have application for other fruits and vegetables here, but our main focus, especially in the next 6 weeks or so, are going to be tomatoes. And that's all conducted here. We pasteurize. Well, I don't even actually pasteurize. We just hot break our juice with a tube and tube heat exchanger. This can be used for something like a pasteurization step or a continuous cooking step or something like that for beverages. If you're trying to make a new, I don't know, orange juice beverage, any type of beverage, we can use our tube and tube heat exchanger. All of this is very versatile. There's different applications, of course. Typically, we use it for tomato research just because we're pretty comfortable with that, and we always have a project with tomatoes going on. All right, any questions about tomatoes before I move on to extrusion and snack foods?
One quick question here, Matt, and that is, how can students get involved in research here?
Okay, that's a great question. So typically, and Gary will agree with me on this. Gary and I are very easy to work with. If you're in food science and you want to use the plant for any reason, you'll contact us. We'll ask you what you want to do. We'll have you fill out a questionnaire, and then we'll see if that project is accomplishable. If it's something done for either undergraduate research or graduate research, if you're working on something to get your degree, we're going to work with you. We're going to make sure that project gets done. It isn't necessarily limited just to that for students. If a student wants to start a company, which we've had happen before, students within the department or within the university hear about us or had lab class down here and they want to start making their product. It's the same sort of thing. The only difference is we kind of operate a little bit differently, as you are no longer operating in a university capacity at that point. So you would be charged for the time and equipment you use here, but we still will help you develop your process as far as knowing what equipment to use down here, teaching you how to use it, showing you the correct, safe way to use and produce your food. But we're very reasonable with our prices for, at that point, they would be food industry. But anyone within the department or in the university, it's a little bit different within the university as well. But if you're in the department and you have some kind of product development competition, we do that with a lot of the students here, undergrad students here, or if you're doing undergraduate research, just shoot me an email and we'll figure out how to help you out and get your project going. All right, hope that covered that. We're going to move on to snack food production, cereal production, and our food extruders. Currently, we have 2. We're going to get a 3rd one very soon, which is very, very exciting. That one's a little more high tech, and obviously because it's a lot more new. But our first one is right here. This is our single screw extruder. It's an Anderson extruder. This is typically used for an application in pet and animal feed. And I know we've been talking about human food this whole time, but we are an FDA inspected facility. We're an ODA inspected facility. And when you get animal feed and pet food made, they also have to be up to human feed and human food regulation, because you never know, somebody might eat that. So we have used this for trials and tests with animal feed in the past. That's not the only thing we'll do. Extruders, the most stereotypical general application is for expanded or puffed foods. So if you think of your cereals like Captain Crunch, if you think of your puffed snacks like Cheetos, cheese puffs, anything like that, this has the capability of doing that. When I say single screw, it's just that inside this barrel, there's only one screw. I can actually open up. You could probably see it a little bit. We only have one stainless steel screw. That just means that it's a little less versatile. We'll take a look at the twin screw here in a second. It's a little more narrow in its application, but it still can accomplish a lot of those expanded and extruded foods, just not to as extreme of an extent. So that's our single screw. We also have back here in this corner, we have a twin screw. We're going to be getting, like I said, a new twin screw extruder. I'll explain why we need a new one and the application for that specifically, but this does a lot of the things that does, but as I said, it has more variability. We can change our flights out, which are the screws themselves and their profile to get a different product. We can use it for puff snacks, but we can also use it for other applications. Something like this could be used to actually be making confectionaries and candies like Jolly Ranchers and gummies. This can also be used to make your dried pasta you get in the store. This would be running the product through at the end of your barrel. You would have a vacuum pump to kind of prevent that expansion and release of gas, and you could get dried pasta out of a machine like this. So this thing is very consistent. However, it is, I think at this point, almost 40 years old. It's a little outdated. So we're getting a new one here, and I think between 8 and 10 weeks or so, we're going to be having a new unit. And the biggest application there is kind of a big trend within the food industry as a whole right now are meat analogs, or as my wife calls it, fake meat stuff. The new extruder we're going to have is going to have the ability to have a cooling die at the end of the barrel so that we can actually produce meat analogs. So if you're thinking of, I guess, like Tofurkey or any type of, vegan meat, we'll have the ability to process those type of products here in-house, which is really exciting. There's a lot of applications for that, and it's a really one of the biggest growing sections of the food industry right now. So we do our best to make sure we prepare our students and then also give the food industry opportunities to utilize this area with whatever emerging technology there is. You'll see that definitely in Gary's pilot plan. He has a lot of new shiny toys. I'm getting my new shiny toy soon, so we're very excited. And I believe as far as the tour, I don't have too much more to show other than odds and ends. Do we have any other questions? I accidentally messed up my timer, so I don't know how much time I have right now.
You're doing great.
3 minutes.
We don't have any questions at the moment, but if you do have any questions, please type them in quickly so we can ask Matt while he's still on camera. But I will ask Matt, how is the process for getting projects into your pilot plant? How does that happen? Is there a process for that, or can you explain that a little bit more?
Sure. So we kind of, the way that it operates for students is very similar to the way it would operate for industry. So either we reach out, we find you, we have a meeting, or you reach out to us. We start an initial dialogue. You would just say, hey, we're looking to accomplish this. The next step would be we would send you a questionnaire just to see exactly what you're trying to accomplish. If you have an idea what types of equipment you need to use, or if you have a process already in mind. From there, we would take that information. We'd meet internally. So the Food Industry Center is made up of Dr. Alvarez, Heather Bell, Steven Simmons, myself, and Gary Winokur. All of us have plenty of experience working with industry and working on these projects. We usually have a meeting of the minds, kind of decide if we are capable of doing the project. Spoiler alert, most times we are. How we would be capable of doing that project and what we want to do going forward. At that point, we would meet with you, ask you any questions we have, make sure you understand where we're coming from, and then we would either quote you if you're ready to move forward, and then start looking at scheduling a date for you to come in and begin the process. And that's if you're coming in and doing the processing, or we would start to go down the avenue of if you want us to conduct that research or project on your behalf, so you don't have to come out, we would start to kind of organize and figure out our process of how you want us to proceed. And it all ends before we start doing our actual processing. We do have a contract in place, and that would include liability insurance, things like that. We also have to include things like if you need to have an NDA, if you don't want us to talk about it, that's cool. I don't talk about anything specifically that happens on here. So, but if you want to have it on paper, that's well within our wheelhouse.
Great. And we do have a question from an attendee. It says, how much of the center's activity is research-based and how much is related to industry? So how much do you have one versus the other?
So I would say my time, it kind of depends on the season, right? So during the summer, we don't offer any lab courses with the food science department, or anyone's going to be using this area for labs. And undergraduate research kind of dips in the summer, as well as like undergraduate projects. So around this time of year, it would probably be 70% industry. This year is a little bit of an off year, just like last year, because people getting back into farmers markets and product development, just because of how things are starting to kind of pick up again, is a little slower. But typically in the summer, that's my busy season for industry. And then during your semesters, it's almost all research. So my time would be kind of the opposite at 70% departmental activities between lab classes, research. We do have external research and lab classes that also utilize the area. And then 30% within the industry, either product development or entrepreneurs. It starts to become harder for entrepreneurs just to get in for scheduling, because we typically try to prioritize the department and education first. So if I have a lab class scheduled for a Wednesday, I can't, and that's the only day you can come in. We're going to have to push you back a couple weeks or move you around, just because we're putting, our students and our education typically are top on the chopping block. All right. I hope I got everyone's questions. I think I'm almost out of time.
Yes, we answered all the questions, and thank you, Matt, for showing us around the first pilot plant.
All right, thanks for having me.
Thanks. And now we will start shifting over to our second pilot plant, the dairy pilot plant with Gary Winokur. Gary has many years of experience and he's been with the Food Industry Center for quite a while. So he's very experienced. And if you have any questions at all, he will be the guy to answer them.
Yeah.
So handing it off to you, Gary.
All right, thank you very much. My name is Gary Winokur. Welcome to the Brewster Dairy Pilot Plant. We have a 3,000 square foot facility here. It's pretty small compared to what you just saw at Matt's. Is about 9,000 square feet. But our number one goal is students, hand-on teaching for our students. Then we do research work, and then we do work with outside clients. So we do run the whole gamut. And during the school year, we're real busy with lab classes and research projects. But in the summer, it does slack off a little bit. Matt has more classes than I do, so I have a little bit more freedom when it comes to having clients during the school year. So it makes it a little bit easier sometimes. So for that, we'll go ahead and get started. I do want to mention that we do any kind of fluid milk in the facility, fluid milk, like Dr. Alvarez said, ice cream, yogurt, cheese. We do evaporation. We have butter churn, membrane technology, and CIP. We'll go through everything real quick, and I'll try to explain a little bit about everything. But we do get milk from the Animal Science Department right over here at Waterman Lab. We do have a couple separators. This separator here is about 60 years old. It still works. It works well. It's not the most latest and greatest. Right next door, this is a brand new modern, it's about a year old, but it is a modern separator. I prefer using the old separator because there's only about 65, 70 parts to clean on that one. On this unit, there's about 160 different parts that need to be cleaned each and every time. And the machine all has to be taken apart by hand. We take it over the sink, we clean everything by hand. This is not an automated cleaning process. We do have separation discs. Both units have separation discs. We use centrifugal force to separate our milk. Product goes in, cream comes out, and skim milk comes out. So very similar. With the modern machine, we have pressure, so we actually can dial in or add pressure so that we could get a certain amount of fat in our, if we want skim milk, we could adjust the pressures and get skim milk. If we want 1% milk, we can adjust our pressures. We could have a stream of 1% milk and the rest of the cream coming out. So cream is the higher dollar value. So cream, we use this separator to separate our cream before we standardize our milk. And standardization of milk is so much skim, so much fat, you put them together and you get your 1% milk, 2% milk, whole milk, etc. So in this area, we can separate, we can blend our products over here in this area. And the next area we have here, this is what we call a pasteurization unit, or we can also do ultra high temperatures. So normal pasteurization, 161 degrees, 15 seconds, 16 seconds. Ultra high temperatures, I don't know if anybody has seen this product on the store shelf. This is in the store shelf, usually in the baking aisle. It's milk product. It's been ultra high temperature processed. All right, what does that mean? The same milk that you would process for 161 degrees for 15 seconds. This milk, you have to process it up to 286 degrees Fahrenheit. You need to maintain sterility of the milk. You need to sterilize the container. The two come together. The product is filled, the container is sealed, and it comes out. So we do not have an aseptic filler, but this is a great tool for research because we can do a variety of temperatures, a variety of hold times. So this is a great tool for research. If you give me 1 gallon of product to start with, I'll give you a half a gallon of finished product at the end. So you can see how it reacts to the high temperatures, low temperatures, longer hold times, etc. This unit here, this is our pasteurization unit. We are in the process of getting this approved by the Ohio Department of Agriculture, which means that once this machine is approved, I have approval from Ohio Department of Agriculture, I can actually sell products to the public. Currently, I cannot sell any products that I make here in the pilot plant, strictly for lab class, strictly for research. And if I do work with a client, that is strictly for R&D. They do not sell the product. They cannot sell the product legally, but I have many companies that come in, and if they want to change an ingredient in their product, they normally need to check it out, test it first to make sure it doesn't make any drastic changes to the product, either finished product or the color. So they would come in here. We could do it on most companies. We do on a small scale. Most companies do on a large scale. So we can do the exact same process. We can mimic the process they want, and we can get finished product samples so they can determine if that's something they want to pursue or if they want to try the new products. All right. But this is a pasteurizer unit. And once again, we just have a product is fed in the tank, product goes in, product comes out, it's safely pasteurized, it's heated and cooled. All right. We do have a homogenizer that's tied to the pasteurization system. The homogenizer will provide us a steady flow of product through the plate and frame heat exchanger. And what we need is a minimum for pasteurization. It's a minimum time and a minimum temperature. The homogenizer provides us that minimum or the whole time, a nice, steady, even flow, as well as the homogenizer will break particles, make them very, very small. Just like when you have milk, you don't see your milk, the fat doesn't separate in a plastic jug. Because it's been homogenized, that means the cream and the skim milk have been put through a homogenizer. The particles have been broken down very, very small, a nice homogeneous mass. It won't separate. So pasteurization, we just want to make products safe for the consumer and increase the shelf life. Our next piece of equipment we have here is what we call, it's a GEA membrane system. So what we actually have in the back here, we have these stainless steel tubes, and inside those tubes, what we actually have is a membrane filter. All right. This filter is designed with certain hole size, certain pore size. So we put the product, force all the product in the entrance. All right. As it travels through, anything that's small in the product will leach out or permeate through the membrane. So this is, if we want, so we can concentrate our product using membrane technology. We have different types of membranes: ultrafiltration, reverse osmosis, UF, and ceramic membrane technology. So we can remove salt from water, we could remove vitamins and mineral, or we could remove different things from products. We could concentrate them. So you could either use the permeate, which is what permeates through the membrane, or the retentate, what we retain. So we can make all different types of products with this machine. We also have our next section here, we have ice cream freezing equipment. In the corner back here, I have a continuous ice cream freezer that you need to supply a continuous supply of product at the entrance of the machine. At the X of the machine, depending on overrun, 31 to 62 gallons an hour will be coming out. This will be frozen. We'll need to collect it into containers or whatever. So overrun, I'll mention that right quick. Does everybody know what overrun is? That's the amount of air that's trapped in ice cream mix. All right. So if we would go to the store, buy a gallon jug of ice cream, plastic jug of ice cream, we bring it in, set it down, we stand around for about an hour and a half, 2 hours, watch it melt. We open the container up and pour that into a measuring container. We'll have exactly a half gallon of ice cream mix, and the rest of the product that was in that container is air that's trapped in the ice cream. So legal ice cream is 50% air, 50% ice cream mix. So that gives us our overrun. So either 31 to 62 gallons an hour. These are smaller. This is a smaller continuous ice cream freezer. You put the product in the top. You have a freezing chamber, and you'll have frozen ice cream coming out here, a continuous flow. This is a batch. These two are batch ice cream freezers. So we simply put our ice cream mix in, we freeze it, and we pull it out. That's a batch. So different from the continuous. Once you put the ice cream mix, you got a continuous flow of ice cream. And one of our favorite machines is our soft serve machine. We have chocolate, vanilla, and we could also have twist. We just have two freezing chambers. One valve in the middle will dole out half of each. So we can put strawberry and vanilla, chocolate and vanilla, vanilla and chocolate, whatever. So we could have a twist. All right. Very popular. Is there any questions so far? I know I'm talking fast, going through a lot of things. Is there any questions that somebody would like to know about?
Not quite yet, but I will
Okay.
ask you, can you talk a little bit about some of the research projects that might be happening around this time? You talked about some of the equipment and some of the products that you can make, but are there some research
Um,
projects you'd like to talk
yeah,
about?
yes, ma'am. Currently, we're doing a lot of, it's kind of a top secret. We do lot of different projects for a lot of different people and a lot of different companies. I've learned over time, I don't talk about who I work with. Normally, I don't talk about who I work with or what I've done with them, because if I start talking about other people's project, the word's going to get around that Gary can't keep his mouth shut, or Ohio State, they can do this stuff, but so I cannot give you a whole bunch of details, but we are using membrane technology. We're producing a new product. And I'm like, it's from buttermilk. We're using buttermilk, using membrane technology. That's those ingredients that we get from that membrane processing are used as ingredients for another process for this client. So we currently have a membrane project going on. I also have several ice cream projects going on with, some people in the state, a couple companies within our state. And I've been doing some ice cream projects with them as well. So right now, research is a membrane technology, and then some client projects have been some ice cream mixes lately. So as we'll move on, this is my spray dryer. If you, so I make cheese I do make cheese, but as many people know or may not know, 100 pounds of milk will give you 10 pounds of cheese, and you got 90 pounds of waste, which is cheese whey. All right. So what we might want to do is take that cheese whey, get rid of the water so we can make a concentrated whey protein. With this spray dryer, this is exactly what I can do with the whey product. The waste product now can be dried. It's a high protein. That WPC, whey protein concentrate, is used in a lot of baby formulas, bread recipes, biscuits, etc. So it's an ingredient that's used a lot. It boosts the protein. It gives you a similar mouth feel as fat. So you can cut down on the fat of a product. You could add some whey, which adds protein, but it also adds a similar mouth feel as fat does. So you're substituting fat for the whey. It gives you a similar mouth feel, so we could trick the mouth into thinking, ooh, that's fat, that's good. So this is a spray dryer. We can take a liquid product. We heat this chamber, the internal chamber, we heat it up. We have hot air that's brought in, it's heated. It's forced through the opening in the top. We have an atomizer that spins. So the little droplet of product turns into a whole bunch of small droplets. As they shoot out from the atomizer in the center, in this hot air, it turns to a powder. The powder hits the side, slides down to the bottom. It comes up here into our cyclone separator, where the particles are normally heavy. So the particles will fall down in our collection chamber here. All right. And then the air will be traveling through our bag house. So the small particles that are left in the air will continue to travel into our bag house. And inside here, I have 4 sock-like filters that are about 4 inches wide, about 2.5 feet long. So those will collect any of the small particles. And once again, we could collect those particles at the bottom. So this has been a fairly new piece of equipment that one of our professors got for us, and it's been a great, tremendous help in the department for different projects, especially for class and or research. So next thing we have are our cheese vats. I have 2 automated 50-gallon cheese vats, and I have 6 5-gallon cheese vats. So these cheese vats we were just discussing, these cheese vats are about 50, were made in 1954. 55. They're still here in the pilot plant. I've done some work on them, but they're still usable and functioning. But this is a great 5-gallon batch size, is wonderful for research. You could have several different batches going at one time. All these are individually temperature controlled, but you'll notice these are square containers with corners and edges. All right. The industry has moved away from everything. Everything's a smooth, continuous material. So if you look in the modern cheese vat, there's no edges, there's no corners for bugs to hide in. It's easier to clean, it's easier to maintain. You have a cleaner, safer product. All right. You have to maintain cleanliness in everything we do in the food industry center. So these are 50 gallons. Normally, in most cheese companies in the state, most of their cheese vats are 5,000 gallons. So cheese vats are usually rectangular and they're big enough that you could swim in. So, I mean, these are very, very small compared to industry, but we can mimic exactly what's done in industry. Next piece of equipment, very new, is a evaporator, vacuum arising film evaporator. But so if I make my cheese, I collect my curds, I have a bunch of whey. I want to take that whey. I could put my whey in here. I could add a vacuum so I could heat the product or get it to boil quicker and easier. I have a calandria where the product goes through. It gets heated up in the calandria. It comes back into this is my product chamber. This is the condensing chamber, but we actually can boil the product. It'll turn to steam. The steam is sucked down into here. We condense it to water and it's eliminated, and we concentrate our product. So once the product is concentrated, I take that concentrated product over to my spray dryer. I could spray that and make a whey protein concentrate. So, or we could evaporate whatever you might want to evaporate. So vacuum evaporator. The next machine here, this is called a continuous butter churn. We're the only university in the United States that has a continuous butter churn. The professor that got this doesn't really care about the butter. He wants the buttermilk. That is the byproduct from making butter. So normally the butter, when you're making butter, the butter would come out here. You have a continuous strand of butter, about 3 inches, comes out round. And during the process, we collect the buttermilk. They found the professor is doing a lot of work with, the hospital complex, as well as nutrition department. They found that some of the products contained in buttermilk are great for brain development in infants as well as in vitro. So very exciting research going on, very important research in the brain development of fetuses and young children with buttermilk, or the products from buttermilk, okay? Another piece of equipment we have is, it's called a fouling skid. But once again, we have plate and frame heat exchangers. This can process product, pasteurized product, or you can do ultra high temperatures with these products. But this machine was designed to measure fouling. Fouling is the amount of product that builds up on the plates as you process product over continuously. So as you heat the product up on these thin metal plates, eventually you'll have what's called burn on, which is product that starts to stick to the heating plates. So there's some equipment on this machine that the manufacturer is saying that these piece of equipment can determine when your plate and frame heat exchanger is starting to foul. And they also do cleanability studies to see how easy or hard it is for the product to be cleaned off, et cetera. But this is a two plate and frame heat exchangers. We heat product up, we hold it for certain lengths of time, we cool it down. But this is strictly more for research activities on fouling and cleanability. So that's our fouling skid. One of our other pieces of equipment that is valuable to the industry is called CIP technology. All right, CIP technology started back in Ohio State Food Science Department in the mid-40s. Clean in place. So we have pipelines in facilities, all right, like these stainless steel pipes. These are actually clear so you could see it, but clean in place technology. We don't take those pipes off the wall at the end of the day, take them over to a real long sink with a real long scrub brush and clean those out, all right? We use water at certain velocities to rinse the system. All right. Then we use chemicals at certain concentrations, certain temperatures, put the chemicals through the system to clean the pipelines. This CIP technology works just as well with tanks and vessels. But this technology this is called a spray ball. So you deliver water or chemical through the spray ball. The spray ball is inserted into the tank, or is in the tank. Actually, there's a spray ball in this tank. So the spray ball delivers water. You have holes designed, so when this lid is shut, every surface on the inside of this container is touched by chemicals or water at certain velocities, certain concentrations. So this tank is cleaned automatically. I don't open it up. I don't take soap and water and scrub brush, clean it out. With CIP technology, I could heat my water up at certain concentrations, automatically delivered to these vessels. Tanks are cleaned. CIP technology brought on mega farms, mega production facilities, because everything can be cleaned automatically. We've removed the human factor out of it. You still need someone to turn the machine on. You still need someone to validate that all your pipes and tanks are getting cleaned. But CIP technology revolutionized worldwide production of food and products throughout the world. Is there any questions that I might be able to answer at this time?
No questions are popping
Alright.
up right now, but I think you answered all of everything that we wanted you to answer today. Thank you so much for your time,
Wonderful.
Gary.
Thank you very much.
Great. So now I will talk very quickly about the courses and trainings that are provided through the Food Industry Center. There are a variety of online and asynchronous courses that you can sign up for. So there are virtual on demand, virtual live, and in-person trainings that can happen. So there are a variety of trainings. We can provide the link for this. But there's a lot of valuable information and certificates that people can get if they are involved in the food industry. And now we will hand it off to Stephen. Stephen is also able to answer any questions that you may have about any trainings offered by the Food Industry Center. But Stephen has a great project that he's going to show us that he is working on currently.
Thank you, Dara. So as Dara mentioned, my name is Stephen. I'm Stephen Simmons. I am a program specialist with the Food Industry Center. I work alongside Gary, Matt, and Dr. Alvarez, as well as our program manager, Heather Bell. And what I'm going to show you today is actually a project that we're working on here in one of our shared use labs in the food science department. It's actually a teaching lab. So during the semesters, the majority of the activity in here is geared towards academic coursework. But luckily over the summer, we have access to all the shared equipment. And currently we're running a project here with a client that will remain nameless. So much like Gary talked about earlier, we do maintain confidentiality here, and we do have a non-disclosure with the client, so be a little bit vague with what we're doing. But what we're doing here today is a shelf life study for a manufacturer of different baked products. So they have lines of crackers and cookies. And what we're doing for them is validating the shelf life of their different products. So we actually have 56 different samples. That's a number of replicates in addition to a variety of different flavors and SKUs. So Dean over here, one of our undergraduate interns, is helping us out today, and what you see him doing here now is running moisture analysis. So what he's doing is he's plating the sample, placing it into the chamber, and then as it runs, it will evaporate the water, the moisture in the product, and it will give us a value of moisture content. So there actually wasn't any product in there right there. So again, trying to maintain confidentiality. In addition to the moisture analysis that he's doing, he's also doing water activity. And water activity is a measurement that's very important for shelf-stable food products because it is important for microbial safety. So with these products being shelf-stable, we need to monitor the water activity of those materials so that we ensure that they're at safe levels and we don't have to worry about those pesky pathogenic microorganisms. So something else I'll show you, we're not using it today, but back here is another shared use piece of equipment. We have a texture analyzer over here. So oftentimes it's used for different baked products, shelf stable, low water activity products where we're trying to maintain a specific texture and mouthfeel. And we can use equipment like the texture analyzer to ensure that we're meeting those expectations. So in addition to these pieces of equipment that you see here in the lab, we do have, the Food Industry Center does have a laboratory that we're not using currently. It's, we're running a project here, so we wanted to show you that. But we have a number of other equipment, other analyses that we can run. So we do have the ability to analyze protein content, moisture and solids in a product, ash, fat content, pH, the list goes on. So we have a variety of applications and different analysis that we can conduct for clients and for students. So Matt took a little bit of my thunder earlier about the process of coming on board with a project through the Food Industry Center. Most of what I do is contract work with entrepreneurs and industry clients. So what Matt was speaking mostly about, and Gary, those types of opportunities for clients are really more a facility rental type projects. And what I mainly do is manage our contract research. So a project like this, where the company wants us to validate shelf life, or if they have a product that they would like reformulated, or even we have a project coming up where we're working on process improvement, process development. So they have it's a client with a current project or product in the market, and they're looking to improve their process and improve the quality of the product, and they're working with us to do that. Essentially, proof of concept work and assistance with process development. So just a brief kind of introduction to one project that would work on. This is a shelf life project, and as I mentioned, we really run the gamut with different types of commercialization type applications. So anything from product development, anywhere from a recipe that someone might have in their home kitchen that we can assist them in getting it to market. We love those opportunities. Those types of projects are really what drive us here. We want to give back to the industry, and the best way to do that is to get new food products out there. So with that, as Dara mentioned, I can also answer any questions that you may have about our training program. So we do have a variety of courses, as she mentioned, for industry, and those are online and in person. So yeah, feel free to ask any questions.
Great, thanks, Stephen. We do have a question. It's more of a general question. There
Sure.
are food taste test sessions that people always hear about. Is the Food Industry Center connected in any way?
Yeah, so that's a great question. So the easy answer is no, but the hard answer is we can be if you need us to be. So there's a center within the department, the Sensory Evaluation Center, and essentially they're a sister center to our unit. And oftentimes clients that we work with also want to do consumer sensory testing or taste testing like you're talking about. And we can work with the Sensory Evaluation Center to conduct those tests. And oftentimes they're run directly through the Sensory Evaluation Center. So we would kind of have two kind of concurrent projects, one with us and then one with the Sensory Evaluation Center. Or if you already have products that are established, or you don't need services through the Food Industry Center, we can definitely point you in the direction for consumer sensory.
Great, thanks, Stephen.
Thank you.
All right, and we will end our tour here with Stephen. If you have any more questions, you can always reach out. We will provide contact information for everyone involved, and for the Food Industry Center itself. If you have follow-up questions that you would like to ask, we will follow up with an email eventually with more information if you would like that. And I would like to give a little plug for Shiftology. Shiftology helped us produce this virtual tour today, so we would like to thank them for helping us do this and produce this and capture the recording that we can then share with more people in the future. And then we will put up the contact information here. Thank you all for logging on today and joining us for our first Tour Tuesday, and please join us for our other 2 Tour Tuesdays. Thank you.